Recently I made a video about a smoke machine that I bought from a UK supplier, and it was a prominent UK supplier, and as such it was fully 100% compliant with the electrical regulations. It was safe to use. Then I decided, well, let's go online, let's go on eBay, and we'll buy a similar machine with the LEDs in the front, and this one actually has a remote control for it. But it's the same style of machine, same style of case, very good chance it comes from a similar factory. So I thought, let's see what it's like before that all the problems have been corrected. So this one came from an eBay seller in the UK called Smart-Tech-Mall. And it's one of these warehouses that they hold the stuff locally in the UK but ship it out, but it completely circumvents all the safety regulations by providing an alternative route into the country. This one cost £23.36, which, to be honest, the one from CPC cost something similar, particularly because they often have it on offer, so no great saving. I mean, it's remote control, but then that's a problem in its own right. It now says doesn't post to Isle of Man since I bought one, because that's what they sometimes do. So there is a remote control with this. There's the remote control receiving dongle that plugs into the XLR connector, and you get this little remote that it's got the telescopic antenna, and then you can control stuff. I haven't tried this yet. So the first thing that went wrong here is that the lead that was supplied with it is not UK compliant. It has no fuse in the plug, but there is a fuse locally in the unit. But this fact that the plug is this style, and it's just basically hints that the flex is probably not copper in there. It might be copper coated aluminium, but that's just a guess. But anyway, I digress. Let's plug this in, right? But not actually plug it into the mains yet, because you get different versions of these. You get the ones with the button remote, and you get the one with the RF remote. And if you get the one with the button remote, it's the same thing with the XLR connector, but it's just a physical button on the front. In this case, it's got a little bit of receiving circuitry. We'll open this up afterwards and take a look. But it plugs into the XLR connector, and you can use standard 3-pin XLR leads then to extend it. So supposing, for instance, that you decide to extend it either to a manually operated button, or because it was a bit of a distance away and you wanted the remote maybe didn't actually, the signal was being blocked in some way. So you could get an XLR lead, and this one, I should confess, it's not an audio lead, it's a DMX lead. Same sort of thing, but different. And let's say, for instance, that you then ran an extension with loads of these leads, and they might be the type that has the screen connected to the shell. That's the audio industry is very, you could ask 10 audio experts about whether you should connect the screen to the shell. In reality, it depends on the type of installation. But let's say that you threw this across with loads of other cables, and then you connected your unit to some random cable, and then there was another one lying there, and someone said that must be the microphone cable, and you were to plug the microphone into it. This nice metal-bodied microphone, it's so good to hold. A nice good fit in your hand. Let's see what would happen in that instance. So here is a meter set to continuity, and let's just check from the live connection of the plug, that's the 240 volt connection, to the microphone. Oh, that's direct continuity to the shell of the microphone for 240 volt supply. Excellent. That's not going to end well. If you go on YouTube, you can find videos where there have been electrical problems, and wired microphones pose a huge hazard for if either the stage, the performer becomes reference to mains from leakage in the stage, and it finds a route to ground through the microphone, or if the audio circuitry, the microphone itself comes live with respect to the stage, or most commonly with respect to their guitar. The microphone versus guitar, there's a potential difference between them. What happens in that instance is, because of the shape, your hand clamps onto it. You cannot let go of that microphone. It's a great electrode. And one that comes to mind is you see the guy's hand just go straight up to his chest, and then he just keels over. It's dramatic. The other thing that could happen is that you could be fishing about for the cables and say, there's my cable, and if it was the screen shell one, then grabbing hold of that, as soon as you grabbed hold of it, your hand would clench because there'd be current flowing, and that in its own right could pose, well, a fatality risk. So I'm not a fan of, rather predictably, I'm not a fan of using low voltage audio visual connectors for 240 volts. Let's open this up. So the arrangement is the usual arrangement here. We've got the fluid tank. Is the fluid tank wet or dry? It's bone dry by the look of it, which means that they've not tested this before it went out, as many of the other ones are. There's usually a bit of liquid in them. It's got the sintered brass air stone, the sort of filter stone that's often used in pneumatics for silencing. And they're using that as a weight and a filter, so it goes into the tank and the liquid's sucked up this stem. Let's pull that off so that we can get the lid off this and we'll see what's inside. Let's get the cable out of the way, the non-compliant cable. So let's just whack some screws out of this and take a look inside. One of the unfortunate things about the audio industry, the event industry, when people ask me how they can get into showbiz and the event industry, I always tell them, get a proper trade first and then look at the entertainment industry, because if you go straight into it, a lot of your training, which is just basically picking up random snippets without any proper training, will be word of mouth. And the audio industry in particular has this old thing that they've just never got away from, that some people disconnect the earth wires in the plugs feeding audio-visual equipment because they feel it a way to reduce hum. It's not, it's just a way to kill people. But there are experts who will just get really arrogant and defend that. It's just unfortunately the nature of it. So for many ways, if you want to go into the event industry, get a trade first, and then you've also got something to fall back on. You realise that it pays low wages, has very odd hours, and you get used left, right and centre. Here is a lamp driver which has come unstuck with the wires going out. Does this have any remote control circuitry? I get the feeling that this is just going to change. I don't think there's any control over these LEDs from the remote. I think they're just going to flash red, green, blue, cyan, magenta, yellow and so on. So what do we have here? I'm noticing two thermal cutouts. The two thermal cutouts are in a series. That's a safety feature, but you know what? It's not safe enough. That's a bit of a shame. They've missed a trick here. Normally there'd be a thermal fuse to protect against overheating if something went wrong. And that's particularly important with these connectors, because if something does go wrong, if someone does hook it up with one of these and it gets shorted out, even in some instances, depending on how it's wired, if the metal connector lies against a grounded surface and there's no RCD or GFCI present, it can result in bypassing the control circuit here. And in this instance, they've got two. They've got two of these. This one is the main one. It's mounted in the heater block. This one is the last resort. It's going to cut in if that one welds shut. And the machine will still work, but a thermal fuse would have been a better option, because with the thermal fuse, it would have actually just killed the unit completely if it had detected that this had failed. And, you know, instead of this one then potentially failing later on and jamming it on and melting the heater block, as happens with these, it would actually just kill it completely. What else do we have in here? I'm glad to say that the fuse, there's a 10 amp fuse in here, checked. The fuse is actually connected. That's nice. And they've connected the earth wire. Hallelujah. That's nice. There's a little solenoid pump, pumping the liquid up this little tube here, which then goes in here. There's a sort of U-shaped heater in here. The tube is wound around that heater, and then the whole lot is potted into a sort of aluminium or some other blended aluminium and other metal alloy, just to provide a huge thermal mass. And the whole point of these is that when you press the smoke button, liquid gets pumped up here. It's a mixture of glycol and water. It gets pushed by the pump in little pulses. It's a solenoid pump. That's the bit that makes the buzzing noise. It gets pumped into that, and as soon as it gets into the heated chamber, the water component evaporates explosively into a sort of superheated steam, but it shatters the glycol or glycerin type component. It depends the type machine. These days, for cleanliness, it tends to be something like propylene, triethylene, or other glycols, and it shatters them into tiny droplets that then scatter the light, and that's what creates the fog effect. My guess is that this is going to be connected probably in the same circuit as the pump, but I could be wrong. I shall trace the circuitry out. Okay, let's put that aside and I'll trace the circuitry out afterwards, and then we'll try it out. Let's take the lid off the remote. So This is the remote connected by that dodgy XLR lead. I mean, that just instantly wins a fail. That just makes it dangerous. That's why the one from CPC did not have that connector. It had a hardwired cable so that you couldn't plug stuff in. In the past, they've also used these connectors, but the female one for that. And it means that if you plugged an appliance into that female connector, that IEC connector, the appliance could then, the whole metal chassis of it could become live at 240. It's just, nobody seems to give a shit. It's made down to a price, and that also precludes safety. Big, complicated circuit board. Do you know what I see here? That is that arrangement of pads suggests that this chip is a remote control receiver chip. And you program it by putting links in, but there are no links in. And if that's common between all of them, it means that this little remote control might be the perfect thing to take to your local shitty nightclub so you can take control of their smoke machine for fun. Excellent. And just fog the place out. What do we have inside? We have a capacitive dropper, we have a relay, we have the little receiver module, the little RF receiver, which doesn't seem to contain the decoding itself. It then feeds over to this chip here, which will be a dedicated remote control chip. It's called SC2272-L4. So what do I see here? I'm seeing the capacitive dropper here at 680 nano, 400 volt. I'm seeing the bridge rectifier. That's going to this capacitor. And this Zener diode. And that's setting one voltage, but I'm also seeing what looks like it might be a current limited supply. It is a current limited supply via this resistor and a Zener, and then smoothing, and that's creating a lower voltage isolated supply from the main one. But the main supply here will be for the relay. I wonder what voltage that is. The receiver receives a signal from the remote control. It sends the data to this chip decodes it, and then it sends a signal to this, a switching signal to this transistor over here, which then brings in the relay. That's fundamentally it. It's just basically, it's a bodged together thing in place of just the on-off switch that you'd normally find on these, the sort of button. That's more or less it. There is another thing. Oh, that's probably for a button. That might be for a manual override button. Okay, interesting enough. Yeah. I'm just processing that at the moment. Okay, and that then, yeah, if you press that button, if you leave all that circuitry off and you put a button in here, it just brings in that, drives that transistor, but it probably lets you do it as well as using the remote. Okay, that's that done. Right, I'm going to pause momentarily and I'm going to reverse engineer the wiring in this. It's not going to be complicated. I'll be back in a moment. Y'all ready for this? Okay, it's the standard circuitry, but with a few oddities. The live comes in and it goes through a 10 amp fuse. The earth is connected to the chassis. That's really nice. It's kind of, sometimes they just don't bother connecting the earth and Chinese stuff for some reason. The neutral goes through the switch. It's odd to switch it in the neutral. Typically it would normally have gone through live and then been switched. I don't know why they've done that. The switch has a little neon indicator in it and resistor, which is then connected up to live so that when it's turned on, the switch lights up. After that, you've got the two thermal cutout switches in series going down to the heater block. This is where it would have been nice if there's the two switches. There's the one that's operating with the heater block temperature, and there's the emergency backup one. I would personally have preferred the emergency backup one to be actually going down here, because at the moment, if things went wrong, if for instance it was a 2-pin or the polarity was reversed, then there's a risk that all these switches can be bypassed by one of the pins in the XLR. And it just, I like to play safe, I like to allow for things, the worst case scenarios, but they don't seem to understand the concept of worst case scenarios. Talking about worst case scenarios, The live then goes to pin 1 on the XLR directly. So whether this is switched on or not, live is going to pin 1. But initially, when the heater block's cold and it's heating up, the live will also be coupled down to pin 3, which is black, and also the pin 2, which is blue, will have a connection to the live feed through the pump and the LED module, which are both in parallel. And they're just going to be that when you squirt the smoke, the LEDs come on. I have to say that just means that basically every connection on the output of that XLR is going to be at full mains potential and capable of killing. Oh well, not to worry. When the unit is heated up, and initially there's no voltage across this, so all the receiver circuitry is dead because there's no power there. When the units come up to heat, one of these switches opens and then you get 240 volts across the pin 1, brown, and effectively the black pin 3 will be referenced down to neutral via this heater, which will be a very low resistance, and it will pass more than enough current to power the circuitry. So that then powers the circuitry. I've just drawn the circuitry as a block here with the receiver because it's proprietary. It's using one of those dedicated chips. It's just a couple of power supplies as shown earlier, the receiver module and a dedicated receiver chip. And the power also goes through this diode, resistor and LED. That's the ones just tucked down here. Diode, resistor and LED. And that makes the LED light up to show that the machine is ready to go and the circuitry is powered. When you press the remote button, if it's matched to the same frequency, it then powers this relay coil, which clicks the relay in and it bridges the blue connection, which is the pumps, which are already, pump and LED, which are already connected to live. They then get bridged down to between the blue and black, which means they find a current path through the heater, which is that low resistance, and it means both the pump and the LED driver will be powered. Straightforward enough. Let's get this drawing out of the way. I think that's just about everything covered. It also means, as with most of these circuits, when the heater block gets cold, again, when it cools down and one of these switches closes and to heat it up again, you'll lose control. You won't be able to blow smoke out over that time. It's one of the annoyances of these small smoke machines. So let's take this out of the way. Let's brighten the image up just a little tad and take a look at these. So the remote control has the matching chip to this receiver, the transmitter chip, and it's got the 12-volt battery, very typical circuit, the 4 buttons with a little LED. It's got the frequency reference, the little RF driver chip, which comes down to the bottom here and then connects to the bottom of this antenna, which is not this telescopic antenna, which is soldered in at a funny angle, just close to the negative connection but not touching it. It has a set of pads in the back, and one of the pads has been linked, and if I thought none of the pads had been linked to the back of this one, but in reality there's one has a default link in the same position, just with a standard PCB tracks across there, so that's then matched the same code. This does mean that all these units are matched the same code, so this remote will operate every single one of these smoke machines. Nice, that's handy to know. Oh, right, next bit, the little Rgb Color Changer bit. The little Rgb Color Changer has a module, and it's basically a little switch mode power supply with the incoming supply going to a bridge rectifier, a little switch mode chip, a smoothing capacitor, the transformer, and then there's an opto-isolator for feedback, and then it just generates a low voltage supply that's set by a little Zener or Zener diode in there. It then has 3 NPN transistors which are switching the output, and I thought, I don't see any current limiting. So they've kind of matched the output to the LEDs, but to make up for the fact the red LED has a lower voltage, let me see if I can just zoom down onto this a little bit. To match the red LED, there is this extra diode in series with it to raise the voltage up to roughly the same as the blue and green LEDs, because typically the blue and green LEDs will be 3 volt, the red volt will be in the region of 2 to 2.5 volts. So all they've done is add that diode just to make it up to 3 volts. And that's all you're going to get. Right, okay. So now I'm going to go and get some liquid. I'm going to put this all back together. I'm going to get some liquid. I'm going to put it into it. And then we shall see what it looks like. demo time, and it works on all 4 buttons of the remote control. So this is what happens when you activate it. I mean, it's a decent enough effect, but you can't leave the lights on. They only operate while it's blowing smoke out. Let's go back to the bench and just do a final summary on this. So in summary, this is very typical of the imported machines, the smoke machines, typically 400 watt, 500 watt that you find on eBay and other places that circumvent the normal import routes. And there are certain things that you could fix about it. You could change this lead. In fact, if you get a lead like this in the UK, square pin plug with no fuse, the best thing to do is say, well, it's not complying with standards anyway, so just chuck it in the bin. Just chop it up into pieces, put it in the bin and get a proper lead. It's not that expensive to get a proper copper one. But the thing that really riles me about this is that little 3-pin XLR connector, because in the event industry, the 3-pin XLR is used for, well, microphones. It's used for audio-visual equipment, connecting it together. The disco lights, typically in the sort of the higher profile industry, they'd use 5-pin XLR, so there's not so much risk. But you get more mass-produced lights that are aimed at the cheaper market that want to use existing cables or the much cheaper 3-pin XLR connector, and they'll just go with 3-pin XLR. And if you were to plug an extension lead into this and mix the leads up, and someone was to find that lead thinking it was maybe mix it up with the one that was coming out of the lighting desk, and they were to plug a lighting rig into this, it would put 240 through the network, the DMX network. If they were to plug a microphone in, it would put 240 out to the microphone body. If they were to plug it into audio-visual equipment, it would just blow it up instantly. Why on earth are they using that XLR connector for 240 volts? It's very strange. And the annoying thing is the heater block inside looks absolutely fine. The circuitry is mostly okay. The case is nice. It produces a good atomization of fog, and it doesn't do that thing that some of the early cheap smoke machines did, that it blows a lot of liquid out because it had a really poor path. It has a decent vapor path of that long capillary tube, just like the original professional machines had. It's very strange. Very odd indeed. They've gone to such an extent manufacturing, and it makes me wonder. I'll just put this out of the way. In China, do they just not understand the concept of electrical safety? I really don't know why they do that. So if you have one of these machines already, I would say by all means use it, but keep an eye on it. Make sure it's got RCD protection. Make sure that the little dongle that you use in it, I wouldn't recommend using leads to extend. I'd actually label it up saying never ever plug any other equipment into this. Do not ever put another XLR extension lead into it. Just in the case of the ones that are pre-wired, have it locally with your button, or if it's the remote control, just try and mount it somewhere that you know it's going to be within the range of the remote control to actually control it. But that's it. If you've got one already, that's just the situation with that. And if you've already been extending it with XLR cables, then just be aware that, you've potentially had live metalwork floating about, and that could have resulted in an accident. So these things are worth being aware of. It's not the only one of its type. It's lots of stuff like this. You just have to be aware of that. But an interesting unit nonetheless. Slightly disappointing RGB effect, but you know what? I suppose it works, but it's not safe.